Okay, so we are going to be using expanding and canceling, and this is probably the most important skill of this whole unit, because if you can do this, then you can literally do any other part of the rest of this unit, okay? Okay, so we have 2 to the 3rd times 2 to the 7th, okay? So what that means is this 2 to the 3rd means we have 2 3 times being multiplied. 2 to the 7th means we have 2 7 times being multiplied. All right. So, and if you didn't just see, I just double checked to make sure that these are all correct. And what I do is count how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means we have 2 to the 10th, okay? We want to check that in our calculator, and that is 1024. So whenever you have just numbers, you also want to figure out those numbers. So these would be 2 answers you would write out when you got numbers, okay? However, x to the 5th, x to the 7th, okay? So this time we have just x's. Now here we have x 1, 2, 3, 4, 5 times, and then we have x to the 2nd, 1, 2. So how many x's do we have in total? 1, 2, 3, 4, 5, 6, 7. So we have x to the 7th. And because it's not a number, we can't do any mathy math. So let's do a couple of the expandings together. So we have, we have 7 to the 3rd and times 7 to the 0. 7 to the 3rd, this means we have 7 3 times. 7 to the 0 means we don't have any. So my final answer would be 7 to the 3rd. And because it's a number, I figure out what 7 to the 3rd is. 343. Okay. Let's look at this next one here. We have 7m, so this is 7 times m, and that's all we have. This next one here, we have times 3, and that to the 3rd power is only for my m, so that means I have 3 m's. Now, this 3rd power is not attached to this 3, it's only attached to the m. So altogether, we have 7 times 3 times 1, 2, 3, 4 m's, so m to the 4th. Okay, this could be a good answer, but honestly, it's kind of goofy looking. But if I do 7 times 3, that's 21, and then we have m to the 4th. Okay, so this would probably be the nicest answer. You probably will not see this other one. It only works when you have stuff like this going on. Okay, the next one here, we have 5 to the 4th, so that means we have multiplying by 5 4 times, and then we have 5 to the 3rd, which means we're multiplying by 5 3 times. All together, we have 5 to the 1, 2, 3, 4, 5, 6, 7 to the 7th. That's a good answer, but you should also remember how to figure out 5 to the 7th in your calculator, and it's a stupid big number of 78,125. Okay, so once again, you got to be able to do both. Let's do this last one together, and then I'm going to have you guys try some on your own. So here we have 6 times, and then we have b to the 0, so that means there is no b's, so I'm going to leave that. Then we have times 3 b's. Okay, all together we have just that 6, and then 1, 2, 3 b's. And this is my final answer. There's no exponent with this 6, so I'm going to just leave this guy how it is. So once again, the exponent 0 only applied to that b. It doesn't apply to that 6. It's only attached to the b here. All right, I want you guys to try these next 4, and let's see if you get the right answer. All right, in this one, 3 to the 3rd is 3 times, 3 to the 0 is none, so it's just 3 to the 3rd, which is also 27. And the one next to it here, 4 to the a is 4aa. Then we have just one a here. There's no exponent. That means there's just one. And then we have times 7 with 4 a's. All together, we have 4 times 7 times a to the 7th, because there were 7 a's. But we don't want to leave it like this with these two numbers here. It looks silly. So 4 times 7 is 28. So we have 28a to the 7th. Here we had we had 3 2's, and then we had 4 2's. So all together, we had 7 2's. And that made 128. This blue one, we had just the 3 because that x was 0 as its exponent. Remember that 0 is only with the x. Then we had a 4 with 2 x's, and then we had a 7 with 4 x's. So we had 3 times 4 times 7 with 6 x's here. That's x to the 6. But it looks goofy if you leave it like that. So 3 times 4 times 7 is 84, and then we have x to the 6th. All right, so that is how we use expanding. And you guys could see like that can get really ridiculous really fast, especially if your exponents are bigger. So we're gonna learn some rules in the next couple of videos. Using canceling. Okay, so 2 to the 3rd is like 2 times 2 times 2 over 2 to the 7th is like 7 2's. 1, 2, 3, 4, 5, 6, 7. Okay. Now, what happens is if you have the same number or variable up top, what you can do is this cancels, this cancels, this cancels. You cancel pairs. So it has to be pairs that are on the top and on the bottom. Now they cancel all the way through. So if there is nothing left up top, that's a 1, right? Because this is saying 2 divided by 2 is 1. So 1 times anything we throw away, right? Because if we have 2 over 2, that's just 1. And technically those canceled. All right, so that's just like a little side note of what this is like representing. So if there's nothing left on top, there's a 1. Can't leave it as 0 because that doesn't make sense when you're just dividing to make 1. But we're left with 1, 2, 3, 4 2's on the bottom. So we got 2 to the 4th. And remember, we also want to be able to write this as 1 over 16. I checked that in my calculator. Both of these are good answers, okay? We're going to do the same thing, but with x's. So we have 5 x's up top over, we have 2 x's on the bottom. All right, now cancel out pairs. This is a pair, this is a pair. So we are left with x to the 3rd on the top over 1. And you could write that, that's okay, but this looks silly. Whenever 1's on the bottom, you don't really need to write that. It's an invisible 1. So x to the 3rd is your final answer. Well, let's do a couple more. So we have 3 to the 3rd up top, so that means there's 3 3's. We have 3 4's on the bottom. We have 4 3's on the bottom. That was hard to say. Here's my fraction bar. I'm going to cancel out my pairs. So this is a pair, this is a pair, this is a pair. So we're left with a 1 on top over a single 3. And that's my final answer. Let's look at the next one here. We got 7's and b's. Okay, so let's do this. There's 1 7, and then there's 4 b's because that b is attached to the 4 only. On the bottom, we got that 7 with 2 b's because that square, that 2 is only attached to the b. Okay, now I got a pair of 7's, so those cancel out. Another pair of b's, another pair of b's, and that's everything that can cancel. So we're left with 2 b's on the top, so b squared. Nothing on the bottom, so that's 1. This looks silly, so with a 1 on the bottom, you remember you can always just write that without the 1 on the bottom. It does change this. 1/3 is very different from 3 over 1, which is equal to 3. Okay, so these are two very different things, so be careful. All right, let's look at this next one here. Top, we have 4 7's. On the bottom, we have 1 7. So my only pair I can cancel is this first pair. We're left with 3 7s up top with just a 1 on the bottom, and that looks kind of silly. So we have 7 to the third, which is also the same as 343. That was an answer from earlier in the video. Okay? So remember, for the ones on the bottom, it makes you look like a goof. Okay, let's look at this next one. We have 8 and then 3 n's, because that third power is only attached to my n. On the bottom, we have a 2 and an n. Now, these guys don't cancel, but something does happen. These do. So we're left with 8n squared over 2. Now what I'm going to do is I'm going to check this in my calculator to see if it reduces. Okay? Because I just want to check. So I make my fraction, 8 over 2, and that simplifies to just a 4. So it'd be like saying 4 over 1 with your n squared. But once again, having that 1 at the bottom makes you look like a goof nugget. So what we want to do is rewrite this as just 4n squared. Okay? And again, that was a 4 because when it reduced, it was just a 4. So 4 over 1. N squared stays where it's at. The 1 on the bottom makes you look silly. So we have this. All right, I want you guys to try these next two and see what you get. All right, in the first one, we have just an x with 2 y's, because that exponent is only attached to that y, so we have x, y, y. Then we have x to the third, so that's got 3 x's, and then a single y. A pair of x's cancels, and a pair of y cancels, so we're left with y over 2 x's, so we have y over x squared. This next one here, we had 2 y's up top with 9 y's on the bottom. 2 pairs of y's cancel from top and bottom, so we're left with a 1 up top. Now remember, if the 1's up top, we don't get to do like what we did here. And we have 7 y's on the bottom, so we have y to the 7th. And that's the end of this video. Hopefully it isn't too long, but I hope you guys have a good day.